Hello students, welcome again to the new segment. In this segment, we will be looking at some more properties of the KNN classification model. So I have already built a model and that model is M. So let's start with those properties. So the first of the property is the class names. And this represents actually the classes that has taken part while you were trying to build your model, right? So in this model actually has been built with only two classes, so there are two classes of information. Remember that if you want to update this variable, it is going to give you an error message, and it will say that it is only the read-only property, right? So you cannot modify it once the model is being built, right? So this is only the read-only. It cannot be updated, right? So remember those three kind of properties. This property is the only read-only property. It cannot be updated, right? So similarly, there is another property which is called m dot categorical predictors. So it will give you the list of those predictors which are categorical, right? So if there isn't any, it will return an empty matrix. Similarly, there is another very important property which is called the cost. Remember that it is going to be used if you are considering different cost for misclassifying a particular instance. Remember that it is going to be a k cross k matrix where k is the number of classes within your data. And on the rows we have the predictions, and on the columns we have the actual classes. So this first value will mean that its actual class is class number 1, and you also predicted it as class number 1, right? So its actual class is class number 1, and you also predicted it as class number 1. So in this case, the misclassification cost is 0. However, if you predict it as class number 1, but its actual class is class number 2, so in that case, it is going to give it a misclassification cost of 1. Remember that on the diagonal, we have all zeros, right? Similarly, you can update this cost matrix to any other matrix. For instance, if you are doing an email classification problem, right? So in that email classification problem, the assumption is that misclassifying a spam email as legitimate is not that much of a costly thing. Instead, if you misclassify a legitimate email as spam, right? So in order to reflect the differences, you need to appropriately define this cost matrix. And of course, it is going to be used in evaluation. The other important property is m dot mu, which represents the mean of the predictor variables. By default, it is going to be empty. And there's another property, sigma, as well. So by default, these two are going to be empty. The sigma represents the standard deviation of different predictor variables. Once you actually standardize your variables, then these two variables, that is the mu and the sigma, they will have meaningful values. So let's do a quick standardization. Remember that in order to standardize, we need to use a name value pair. The name is standardized, and we need to set it to 1. So then it will scale all the variables. So once that scaling is being done, and then when you recall it, that m.mu, now it is having the means, right? And similarly, the sigma, it will contain the standard deviation. So if you do not standardize, they are going to be by default empty matrices. Another one is the m.x. It contains the original data without the class value, right? So it contains all the data without the class label. And m.y, it contains only the classes corresponding to different instances. Then finally, we have another property which is called m.response name, and it contains the variable which is being used as a class variable. So these were some of the additional properties, and these properties more or less will remain the same for different classifiers. So I found that in order to repeating it with corresponding to each and every classifier, it will be useful to specify it once. And when we are trying to cover more classifiers, so we will not recover these properties. So hope you're enjoying the course. See you in the next segment.